Hello, everyone. My name is Tyler Bell. I'm a postdoctoral scholar in the Department of Psychiatry at the University of California, San Diego. And today, I would like to discuss a project that I've been working on for the last year to examine how persistent pain associates with locus coeruleus integrity in older adults. As shown in the image below the methods in the blue square, the locus coeruleus is located in the dorsal pons and produces most of the norepinephrine in the brain. Lower LC integrity, primarily measured through postmortem studies and histology, is implicated in poorer cognition and increased dementia risk, especially when deterioration occurs in the rostral region. In animal studies, lower LC integrity has also been implicated in poorer pain modulation. However, we don't know if that's true in human beings with persistent pain. We do know, however, that persistent pain is associated with LC-related outcomes, LC being short for locus coeruleus, including things like memory decline and dementia risk. And so persistent pain and the LC seems like an important biological link to determine. And it may even underlie the cognitive effects of persistent pain. So the purpose of the study was to examine people that entered young older adulthood and compare their LC integrity in between people with a history and without a history of persistent pain throughout midlife. We did this by collecting data from the Vietnam era twin study of aging and looking at 387 individuals with imaging data of the LC without a major neurological condition, including stroke, as well as seizures, etc. And then we looked at the longitudinal data to determine persistent pain history. In particular, VETSA has 3 waves of study across 12 years, and on each wave, individuals reported their pain on the SF-36 bodily pain scale, and we examined significant pain as pain more than mild on the pain intensity scale, and individuals that reported this in more than 2 waves or at 2 waves had persistent pain, and those that reported just 1 wave or no waves of significant pain were reported as not having persistent pain. Covariates for this study included age, depressive symptoms, and comorbidities, as well as opioid use, as these things could confound our results. LC imaging was done using novel normelanin signal detection. Normelanin is a byproduct of norepinephrine production in the LC. So if we can pick up more of that signal, that should indicate more LC producing cells and the integrity of those cells. So what we did was for the rostral and the caudal region, the LC determined the normelanin signal, the average signal in those regions, and compared it to a reference region where we shouldn't see a lot of normelanin signals, which we use the pontine tegmentum as done in previous studies. The formula is shown here, but in essence, we z-scored this contrast to noise ratio to make a score for LC integrity where higher values indicate more LC integrity, and then compared them in the groups of people with and without a history of persistent pain. As shown in the results in Table 1, simple t-tests did show a significant mean difference in the rostral LC integrity in people in persistent pain versus no persistent pain, with people with persistent pain having significantly lower rostral integrity of the LC. And this is also shown in the figure in the middle as well. We did not, however, see a difference in the caudal region. And after running this with covariate adjustment and bootstrap analyses to make sure that we got rid of anything that could have been done to the smallness of our sample, we found that this result with the rostral region remained significant. And in conclusion, persistent pain in midlife seems to be related to lower LC integrity, at least in young older adulthood. This wasn't explained by depressive symptoms, comorbidity, or opiate usage, which was not related to the LC integrity measures at all. And pain's effects were mainly shown for the rostral region of the LC, which suggests that persistent pain involves some kind of pathology in the projection sites towards cortical regions that are involved in norepinephrine production and also connected to descending pain modulation. The locus coeruleus may represent an important biological link between persistent pain and cognition, perhaps because these individuals have lower LC integrity, which leads to persistent pain. Perhaps this lower LC integrity also explains why they are at increased risk of dementia and memory decline over time, though this will require future longitudinal data collection to determine. If you have any questions, feel free to reach out to me on Twitter or email, and I'd like to thank my mentors and everyone for helping me on this project. Thank you.